Bismillahirrahmanirrahim. In this video, we'll be discussing practice problem 8.9, and this is also a driven RL circuit. So as we have seen in the previous video, that the complete solution we'll be using. This was the complete solution that we got. This is given in the summary of Mr. Hayt's chapter number 8. We will use this. And this, if you write in terms of I, then for F we replace I, current, then I. Okay, now coming directly to the question. The voltage source, 60 minus 40 UT, so this is the voltage source, is in series with the 10 ohm resistance and 50 ohm inductor. So 10 ohm resistance and 50 millihenry inductor. Now, two things we have to find the magnitude of the inductor current and voltage. Remember, it is the magnitude. Okay. And we have to find it at t is 0 minus, t 0 plus, t infinity, and t is equal to 3 millisecond. And this is the answer given in the book. So let's start. First of all, let's interpret this term. 60 is a constant all the way, 60 line we can draw. Then minus 40 is minus 40 UT. That means it will start from 0. And since it is negative, therefore we'll write 40 UT here at the bottom. And if you add the 2, before 0 it is 60, but after 0 it will be 60 minus 40, because 40 UT is minus 40. So 60 and 60 minus 40 will be 20. So after 0 it will be 20, and before 0 it will be 60. This is the input. Okay, with this in mind, the magnitude of the inductor current and voltage at t0 minus, and this is the point where we want to find the current and the voltage. So if you keep this circuit in mind, and we know that this voltage is present there for a long time, therefore the circuit or the inductor will behave like a short circuit. So we can say that the inductor is short circuit, and the input voltage is 60, and so we can find current from here. So I0 minus is 60 divided by 10, 6 ampere. This is the first part. And now the voltage, VL0. So this circuit, this is the voltage here, and we could say that since there is no resistive element, therefore this voltage will be 0. But it is better that we write a KVL equation. So we write KVL from here, minus 60, 10 into I0, so 10 into I0, and plus VL0. Now I0 is 6, so we plug in that value, 6. So VL0 will be minus 60 and plus 60 will be 0. Therefore, VL0 minus will be 0 volt. So this is the first part. And this is what is the answer given. 6 ampere, and 0 volt. Now coming on to part B. Again, since it is saying 0 plus, that means we're just little ahead. Not this is not correctly drawn, but we're just little ahead. And we know that the current does not change instantaneously. Inductor current does not change instantaneously. So whatever was the current here will be same here. So we can say that I0 plus is equal to I0 minus, and I0 minus we had calculated in the previous slide to be 6 ampere. So I0 plus is 6 ampere. And now coming on to the voltage, again we'll write the KVL equation. Now keep in mind that we are Now in the transient period, we are here. The moment we cross 0, then the transient period starts. That is why while drawing, we will not short circuit the inductor. But the voltage has changed. It is 20, so it will be 20 volt. And we'll write KVL equation for this circuit. So minus 20, I into 10, and plus VL 0. And plugging in the value. Now this was 6, and solving minus 20 and plus 60, so it will be 40. Plus 40 going on this side will be minus 40. But since we are to find only the magnitude, therefore we'll take mag of this, so it will be 40 volt. And the answer given in the book is also 6 ampere and plus 40 volt. Coming on to third part, find the current and voltage at t is equal to infinity. At t is equal to infinity, that means we are here. The circuit is in the steady state condition, and the inductor is now will behave like a short circuit. So the current we can easily find. Voltage is 20 and this 10. So I infinity is 20 divided by 10 is 2 ampere. And V infinity, if we write the KVL, minus 20 I infinity into 10 plus VL infinity. And I infinity is 2 ampere. So 2 ampere, and solving we get this minus 20 plus 20 is 0. So VL infinity is 0. And that is the answer given here, 2 ampere and 0 volt. So 3 parts we have done. But the last part is the most interesting part. The magnitude of the inductor current and voltage at t is equal to 3 milliseconds. Now, let's first of all, for any time t, we have to take help of the general equation. You ignore this for the time being. And this was the general equation. For I, this will be the equation. And we had calculated I0 plus and I infinity, so we'll plug in these values. And also tau is L over R. So L is 50 millihenry, R is 10. So it will be 0.005 second. So putting all these values, I infinity is 2. This is 6 minus 2 e raised to the power minus t divided by tau. And so it will be 2 plus 4 e raised to the power minus t 0.5. So this is our current equation, general current equation. And now we will find at 3 milliseconds. So this is easier than the last question. Simply we find, we plug in t is equal to 0.003, and solving we get the answer to be 4.2 ampere. So this is the current, and voltage we follow the same rule, same technique. So minus 20, and current is 4.2 into 10, and VL will be 22 volt. So I hope you have been able to follow this. Please let me know through your feedback. Thank you.